Welcome back to Corporate Finance. Last time, we applied our forecast drivers to our free cash flow formula to forecast free cash flows for our tablet project. Today, I want to take those free cash flows and apply our different decision criteria to come up with decisions regarding our project. Let's get started. Hi everyone, welcome back to Corporate Finance. Today we're going to talk about decision criteria, but before doing so, let's recap our previous lecture in which we forecasted free cash flows. Specifically, we took our forecast drivers, our assumptions about what would happen in the future, and applied them to generate dollar forecasts of all of the components of the free cash flow formula, which we then built up, aggregated into free cash flow forecasts. Today we're going to turn to what to do with those forecasts by looking at different decision criteria. So let's get started. So what do we do with our cash flows from last time? One thing we can do is we can compute the NPV. And I'm going to assume a discount rate of 12%, that is R equals 12%. And if we do that and apply it to our free cash flows that we computed in the last lecture, what we're going to see is that this project, this tablet project, has an NPV of $708.42 million. Not bad. What that means is that firm value, debt plus equity, is going to increase by $708.42 million in expectation if the project is undertaken. So from a decision-making standpoint, undertake the project. That's what the NPV rule tells us. It says accept all projects with a positive NPV, reject all projects with a negative NPV. And while this has boiled it down to one number, I want to be careful, especially when we start doing our sensitivity analysis, to recognize that we don't want to pin all our hopes to that one number. Now, another thing we can do is we can compute the internal rate of return. The internal rate of return of a project, recall, is the one discount rate such that the net present value of the project's free cash flows equals 0. We've actually already seen this when we were talking about yields. Remember, the yield is the one discount rate such that when you discount the cash flows by the yield, you get the price. But the NPV is nothing more than the price minus the present value of all the future cash flows. Okay. So IRR and yield are really one and the same. So what's the IRR for this project? Well, we write our NPV formula, we set our NPV equal to 0, and then we solve for the one discount rate such that when we discount all of our free cash flows, we get an NPV of 0. If we do that, we find that the IRR on this project is 43.7%. Well, is that good? Is it bad? Before getting there, I just want to mention, typically we're going to need to solve this numerically unless you have figured out some amazing way to solve higher order polynomials. You can use the IRR function in Excel. I think you can use goal seek in Excel. You can try trial and error, though that's really inefficient. If you're using another software program or a financial calculator, you can do this as well. Okay. All right. So what do we do with this 43.7% IRR? Well, we're going to compare it to our cost of capital, our hurdle rate. And what we're going to do is we're going to undertake the project because the IRR is greater than the hurdle rate. Intuitively, it makes sense. And this is one of those cases where intuition actually works. It costs us 12% to raise money in the capital markets, to fund our investments, to create value. If this project generates a return of 43.7%, that's substantially larger than what it cost us to raise the funds. That sounds good. That makes sense. And so what the IRR rule says is accept all projects whose IRR is greater than R and reject all projects whose IRR is less than R, where R is our hurdle rate. Hurdle rate, cost of capital, our discount rate. Now, I do want to mention that the IRR rule is informative. It's also somewhat intuitive and appeals a lot to investors who tend to think in terms of returns, but it's got a number of shortcomings that we're going to explore in greater detail in topic 4, return on investment. Now, one picture I'd like to show you is the following. I've plotted the cost of capital on the horizontal axis and the project NPV on the vertical axis. And what the blue line shows is it shows how the NPV of the project varies as I vary the cost of capital. 2 points are worth noting. First is this point right here, which is the 12% cost of capital of the project, you'll notice that generates an NPV, as we saw earlier, of a little bit over $700 million. The second point I want to point out is this point, the point where the graph crosses the x-axis. That's the point at which the NPV is 0, which, as we know from our definition earlier, is just the IRR. That's 43.7%. Now, I think this graph is, let me clear this up a little bit, this graph is useful because from a sensitivity analysis or a robustness perspective. Look, this R is an estimate, and to be honest with you, it's typically a noisy one. What I see here is I see a really wide gap between my estimated cost of capital and the point at which this project just breaks even. So even if we disagree on the cost of capital and you're taking a more conservative view and you think it's upward, our real cost of capital is 20%, that's okay. This project is still NPV positive. It's still value accretive. And so what this gap here shows is it shows that I've got a lot of room for error, at least on the discount rate dimension. The third thing we can do with our cash flows, our free cash flows, is compute a payback period, which is the duration or the time until the cumulative free cash flows turn positive. So let's look at our project. Here are our free cash flows. I'm going to accumulate them year over year. So this negative 510.4 is just the 376.8 in year 0 plus the negative 133.6 in year 1, and on for years 2 through 5. And then I'm going to look at the cumulative free cash flows and ask, when do they turn positive? Well, they turn positive right here in year 3. So our payback period is year 3. We turn cash flow positive in year 3. Some people might say it takes 3 years to recover your investment. Is that good? Is it bad? How do we know if 3 is good? How does that help us in our decision of whether or not to undertake the project? Well, what we do is we compare it to some threshold. And so the payback period rule says accept all projects with a payback period less than the threshold, reject all projects with payback periods greater than that threshold. But it should be immediately clear that the payback rule, or the payback period rule, has several shortcomings. The first of which is it's ignoring the time value of money and risk of cash flows. The first sin that we learned way back at the start of the course. But fortunately, that's actually quite easy to deal with. We can compute the discounted payback period by discounting the free cash flows, right? The discounted payback period of a project is just the duration until the cumulative discounted free cash flows turn positive. And so on this slide, I've computed those discounted free cash flows using our cost of capital of 12%. And then I accumulate them and wait, or count until they turn positive, which is right here in year 4. So our discounted payback period is 4, which is greater than our payback period of 3. But even using the discounted payback period, this rule has a number of shortcomings. For example, it ignores cash flows after the cutoff, and that's going to lead to myopic decision making. Let me go back a slide. What if this cash flow in year 5 was $20 billion? Well, $20,114 million. It'd be a shame, to ignore that and the implication for that, of that cash flow. So by ignoring those cash flows, you get myopic decision making. Number 2, it's not telling us the value implications of our decision, right? It's not helping us quantify the effects of any decision that we make. It's also not helpful in choosing among projects with similar payback periods. So I've got 3 projects. They all have payback periods of 4. Which one do I choose if I can only choose one? All right, so let's bring this all back together. Let's bring it full circle. So there's several decision criteria. NPV is unambiguously the best and should always be used. But I want to emphasize that others, such as the internal rate of return and payback period, or its discounted cousin, they're all informative. And the key is to understand the shortcomings of these alternative decision criteria to avoid any mistakes that feed into the ultimate decision. So what I want to turn to in our next class is sensitivity analysis, which is an integral component of any DCF. Thanks again, and I look forward to seeing you.